In this experiment, what we're going to do is we are going to use a scale to record a force in newtons. So as an example, here is a Newton scale. And when we hook an object onto this, you can see the harder I pull, the bigger the number. So that tells me right now I'm pushing with a force of approximately 10 newtons. Okay, here's a different version of it. It's a little cylinder. Um, this one goes from 0 to 5. So make sure you don't use anything greater than 5 on this. And here's another version. It goes from 0 to 20. So what you're going to do is you're going to pick 10 random objects around the room. First thing we're going to do is we're going to put them onto a scale to measure their mass. And then what we're going to do is we're going to measure their newtons. And then we're going to do some mathematical calculations and compare the two results. So once again, 10 different objects. You're going to record their mass using a regular scale. And then you're going to measure the newtons using one of these Newton scales, and we're going to compare the two results. And we'll do a little bit of work with our percent error as well, which we can do. We'll do it just for the very last sample that you did. So I've got my scale here ready to measure, and I've picked a random object from the classroom. I picked one of these carts. And so I'm going to start by placing it on my triple beam balance, which I've already zeroed. And then I'm going to adjust my weights. And I'm going to look at this, and I see that this has a mass of approximately 234.94 grams. So I'm going to record that, 234.94 grams. Convert that into kilograms. And now what I'm going to do is I'm going to pick one of my scales. I'm going to use this one to measure the newtons. Now this has a mass side. I don't want us using that. I want us to use the kilogram, the newton side, and you can see that this is approximately, hard to do both at the same time, about 2.35 newtons. So I've recorded the mass from the triple beam balance, and I've recorded the newtons from the Newton scale, and record both of those. And from the Newton scale, we're now going to convert that and calculate what the mass we think it is using our 9.81 meters per second squared, the acceleration due to the gravity, and we'll compare that number to the value we got from the triple beam balance. The 10th object that you do, you will also do a percent error to see how different those two things are. Use the mass from the triple beam balance as your accepted value, and the theoretical value will be the one that you calculated from your Newton scale. You'll take all these numbers, this data, and upload that into a Google form.